Now we are moving towards the second part, that is preparation of hydrogen. Hydrogen can be prepared by many means. Some are discussed as: it can be easily prepared by action of water on metals. But due to the reactivity of the metal, the nature of the water is something different. For example, if active metal is there, for example, sodium, potassium, then they react directly at the room temperature to produce hydroxide and liberate hydrogen gas. For example, sodium, potassium. Yeah. Then we come to the less reactive metal. If the metals are less reactive, for example, calcium, zinc, magnesium, aluminium, etc., then we require heating of water with respect to metal. And if there are, which normally inert metals are there, which do not react directly, or which cannot react easily, then they are steam heated. That means they are passed. That means the water is passed to the red hot metal. For example, iron, cobalt, nickel, tin, etc. The reactions go for this. For metal, for example, if we take for the active metal, sodium plus water gives NaOH. Then we come to aluminium plus water, we get aluminium hydroxide, sorry, aluminium oxide and water. And if you go for iron, it is again the ferroferric oxide, Fe3O4 plus hydrogen. Then we come to action of uh, alkali metal, alkaline earth metal, and water. By action of water on alkali metal and alkaline earth metal hydride, if we take the hydride of this, we pour it with the water, and then we get hydroxides as and the hydrogen gas is liberated. Then we come to action of metal like zinc, stannous, aluminium with alkali. They form zincate and hydrogen gas is liberated. Aluminium when treated with sodium hydroxide, it forms sodium meta-aluminate and hydrogen gas is liberated. Then we talk about silicon treated with uh, NaOH, it forms sodium silicate, that is water glass. Remember, sodium silicate is commonly known as water glass and hydrogen gas is liberated. If we heat the metal with the presence of acid or action of metal with the acid, it liberates again the salt and hydrogen gas is liberated. It can be produced by electrolysis of acidified water. Laboratory preparation, zinc treated with a sulfuric acid, we get zinc sulfate and hydrogen gas is liberated. If we want to produce the pure form of hydrogen, then we take magnesium treated with sulfuric acid, forms magnesium sulfate and hydrogen gas is liberated. The commercial preparation of hydrogen is by Bosch process, Lenz process, and by electrolysis of water, or from the hydrocarbon alkanes also we get by cracking or heating at a very high temperature. Now if we talk about Bosch process, now Bosch process is the process in which twice the volume of steam passed over catalyzed Fe2O3 presence of promoter like chromic oxide or thorium oxide at a high temperature round about 500 degrees centigrade. Then CO2 and H2 is obtained, which is dissolved in water, and hydrogen gas is undissolved in water at high pressure. This is the Bosch process. Now we come to the Lenz process. Lenz process is passing steam over spongy iron, that is heated iron at 500 to 800 degree centigrade temperature, or we can say 773 Kelvin to 1050 Kelvin temperature, we get Fe3O4 and oxygen, water is formed, and this water is converted into, so last process, when we take uh, iron treated with water, Fe3O4 is formed and hydrogen is prepared. This Fe3O4 again treated with hydrogen, it forms iron, H2O is liberated. Again we come to the electrolysis. Electrolysis, again water is electrolyzed and hydrogen gas is liberated. From hydrocarbon we go for cracking, or if we go for steam, or steam treated with hydrocarbon, we form the mixture of carbon monoxide and hydrogen gas, which is at high pressure. Carbon monoxide gas get dissolved in water and hydrogen gas is liberated. Now the next topic, we will take properties of hydrogen.